All right. Hi, I'm Rich, and welcome to another XML tutorial on some interesting stuff that I work with. This one's going to be about XPath and XSLT, which are two programs used for manipulating XML into other formats. So the motivation for this talk is to think about how we might want to change or process or do something with XML. We often want to process this data inside of an XML file in some sort of programmatic way. One example is to convert one form of XML into another form. Another might be to extract element data into some sort of text file. You might also try to use something really complicated like taking an XML schema, which I've given a previous video on, and use it to create the classes for some programming language. And this is actually the main reason why I got into this, and I'm going to do a detailed video about that later. For right now, we're going to focus on basic stuff though. Now, we need a simple way to process data that's in an XML file, and we want to do it based on some sort of a pattern. The idea is that we should have some sort of small program that tells me what I want to do with the data, and then we can apply that over and over again to different XML files on a regular basis. So the idea is that we're going to separate the tasks of getting the XML data from the task of what the desired output of that new data is. A database query is a really natural way to talk about data access because XML files are very structured. And we'd like to, for the formatting side of things, do something with some sort of macro or keyword to just simply say, I've got a piece of data and you're going to put it here and I'm going to surround it with some other junk that I'm going to build the data around, where the build the output around these little data queries. And the result of combining these two things is what you do when you run an XSLT sort of program. Now, to do XSLT, which is the transforming program, we're going to need to talk about something that's a little complicated, but it's key to understanding how XSLT is done, and that's called an XPath. An XPath is a way of finding your way around an XML file, particularly if it's an XML file in the document object model, the DOM module, that you have the whole XML at once. You're not trying to parse it on the fly like you do with things like SACs or something like that. So how do you find your way around it? Well, let's take a look at a schema. This is something we developed in a previous video, and it's not important to figure out what it is, but the point is this is a description of later XML that we're going to see. And it in itself is an XML file. And one of the things that you notice is that there's a regular amount of tags in there, right? There's some structure to it. And they repeat over and over. Certain tags go over and over again, right? So, for example, let's say you want to search through this XSD file, this schema file, and look for things that have the XS element structure, this guy right here. Okay? And I'm going to do something every time I see one of those. But and this one's easy. XS element shows up at the top of everything. But what about name? And name as an attribute shows up in different places. Sometimes it's at the top. Sometimes it's associated with other things. We got elements that are inside of things. There's a more general way of working with this, right? But remember that XSD schemas are just plain XML, so the rules for parsing a schema are the same as the rules for parsing as any other XML. And of course, schemas have this XS prefix, right? The schema, as a quick reminder, these define the target XML in some sort of end XML. So it sort of lays out the format of an XML file, right? Now, XPath is a way of looking around these things, and what we're going to do is we're going to look at the XML file as if it was a file system, right? Like a directory on your hard drive. And that's how we're going to talk about locating elements. But we're going to add a little bit more to it than just what you get out of a command prompt, like a DOS prompt or a Linux prompt, right? But we're going to view these things just like they're in a directory because it's hierarchical, and so are file systems. So vocabulary-wise, each element, which is a tag, each attribute, the things within the tag with the equal sign in them, etc., even the content within there, we call those nodes in this XML document tree. Starting with our root element, our root node, we can descend element and attribute and content through each child of a complicated program. Okay, so that's our idea. Nodes are any stopping point in there, anything useful in there. So we call them all nodes. Now, XPath has this very rich feature set. We can do wildcards. We can do what's called predicates, which is test conditions. We can even do some manipulation of what's inside there. We can do some string processing of what's going on there. So, that's it's a very, very powerful tool, and it's much more complicated than even just what XSLT does. So XPath is really its own world. It's a lot like regular expressions. You know, you've got you learn regular expressions, and no one tells you what to do with them because they're this abstract thing, and then you find yourself using them all the time. So that's what XPath is, right? It's worth the effort to learning this stuff really, really well. So let's look at an example. I've never said what an XPath is. You've never seen one. So let's look at one. This is an XML file here, right? Based off of our previous work on a schema. And this is an example of an XPath. Okay, so we're going to delve into this, but basically what it's saying is starting at the root, find the program tag, find all the program tags in particular, right? But there's only one of them. Then within those, find all the events. Then within those, find all the start times, and check to find the start time that has a value of 15 inside of it. Okay. So let's take a look at what that means. It found this particular line right here, right? So we delved in all the programs, find both the elements, cool, that's there. Find within those both the times, and then find the one that has the number 15. So so that's an XPath used to find a specific tag. And you can see how it kind of does look like a file system directory if we just simply call the tags directories, and then call the end of it is looking for the one with a specific value inside of it. Now let's dissect an XPath and see what it's saying. Here's the one that we just had, and down in the corner is our original file. The first slash says start at the root. Just like in a Linux file system, there are relative paths and there are absolute paths. If you start with the slash, then you're starting at the top of the file. That's not the top of the schema, because you can have lots of things at the top of different schemas. But the file you're talking about, so it's a specific file. Okay, start at the root. Great. This curly bracket is the whole root. Then from that quotes, find an element called program. So we started from the top, then we wanted to find something called program. Cool. Then from that, we want to find event. There's 2 events inside of programs. Remember, we're always going to work with groups. Unlike a real file system, we can have, quote, directories with the same name. So there are multiple events inside that. You can't have directories with the same name in a file system. Okay. Then from the events, remember we have 2 events, find any start times, which means there are 2 start times because we had 2 events, then any start times inside there. Now you notice the size of my little wiggles is getting smaller every time too, because I'm narrowing it down. Okay? So I'm not talking about everything from program on down. I'm talking about a specific thing. I started big. I just said program, that meant everything inside of it. And then I got finer and finer as we go until we got these 2 individual tags. The last element in the square bracket is known as a predicate. It's saying the phrase, find the thing with the number 15. Now let's talk a little bit about that vocabulary, right? NodeSets, cursors or axes, and predicates, and also labels. So we have our expression up at the top here, and we have our destination down here. A node set is the collection of all the nodes. That is everything, content, elements, which is to say tags, and attributes, even comments that match something. So when I said find root, that meant the whole file. Then when I said find program, that meant everything that matches program, which means everything inside of program. So the node set is a collection, always. It's never one answer. I mean, sometimes it is, but in general, it is always a collection. Okay, so that's the node set. The cursor, which is also called the axis in the particular XPath documentation, is this position of the current specific match in the node set. Now, the cursor is moved anytime you find a slash, right? We started out with no cursor. Then we had our first slash at the root, which said, great, I've now started. Doesn't matter what my cursor was before, we are now going to start it again. Just like a file system, absolute pass mean it doesn't matter where I'm at now, I'm going to start over again from the root of the file system. Any descendant, and I don't mean any descendant, I mean any descendant, right? This is not any one descendant, it's any descendants. That's all of the descendants. Can be given by a double slash. Okay, so when you see a double slash, that means find everyone below him. And when you find a single slash, we're finding out specific guys. And the current position is a single dot. The double dot is the parent, just like in a file system. And there's a wildcard in there given by a star. There's a couple of other kinds of wildcards that are worth looking up later on. A cursor is also, again, called the axis. Predicates are what's inside of the square brackets, and they are true-false statements. Now, they do not move the cursor. They're a way of looking ahead without moving into the directory, to stretch the analogy a little bit. And they're used to find matching conditions, just like we did here. We had two different start times, and then we picked a specific one, but we didn't get into the 15. We stayed at the start time, but we looked inside of it without going into it. Okay. So predicates are used to make a filter, essentially. We've been filtering the whole way, but now we're talking about a little bit more refined filtering, and we don't move anywhere. So the node set never changed when we do a predicate. The node set does change. It gets smaller every time. Although there might be more of them, they individually get smaller scope every time we use the slash. Okay. The last thing that we're talking about is labels. And labels refer to either element names or attribute names. And there's a few ones that look like functions that I'm not going to go into too much here, but they also exist. But the point is, it's what's between the slashes or inside the brackets. Okay, so in this case, we have the word program. That's a label. And in particular, it's an element label. So a tag label. We're finding a tag called program. That if it's an element, that just simply means that there was no decorations on top of it. The word program means the element program. That's the simple one. Attributes begin with the letter at, or begin with the symbol at. So if you see the thing at program, that's not an element called program. That's a attribute of the current node set called program. All right. Let's look at these things in just a little bit more detail later on. Here's some fun XPath examples. So we got our friendly program again, and let's look at some examples that show some of these cool features. These three XPaths are exactly the same. They point to the same node, okay, which is this the one that we've been looking at before, this 15. Okay, so we're just going to get to it in different ways. From the root, we look for program, then we refined it to both elements, then we refined that to both start times, then we looked into the content to say it's the one with 15. Cool, we know that one. We'd also do it a different way. We could say look for all events. Ignore, it doesn't matter if they're inside of program or not. Look for any events you find. Then find the start time and the text. Remember, the double slash means any descendant that matches. Okay, so we had root before, now it's any event anywhere, doesn't matter if it was from program or off by itself or whatever, right? Then we could even skip the start time and look at a sibling of it. So in this case, we're going to look at all the laser offs. So that's this guy down here. Then we're going to find the one who has an attribute called channel. That's this here. And its value is Heaney laser. Okay. Then we're going to, just remember, think the directory analogy. Then we're going to move the node set up a parent. So now it's back into the containing event, the second containing event. And then we're going to go back down again into start time. So you can see how we can move up and down, right? We weren't even searching for start time until the very last. And we never actually looked for the number 15. So 3 things, exact same node. They all point to the same node set, which in this case is 1 element. How about the text of each start time? Okay, so remember I said there were some functional wildcards that we can use too, right? So program, event, start time, and then we're going to look in the text of start time. Now this should give us 2 results because we didn't refine it any further. So we should get a number 5 and we should get a number 15. So a collection, just like all XPaths, a collection with 2. In this case, they're strings because I said cast it as text. We could have also refined it further and say, by the way, that text, consider it a double or a number or whatever, an integer. So that's the text inside there. How about an attribute? In particular, the attribute, the units attribute for the one who has number 5, right? Program, element, start time, cool. Text containing the number 5, so that's our first start time. Then it's a predicate, so we're still in the tag. Then find the units, okay? And then find the text inside the units, right? So this is going to give us the answer of microseconds, or US, right? Cool. Here's a fun one. This shows how we can do string manipulation inside there. How about the units prefix, right? You think of the standard unit prefixes, millim, micro, and so on like that. So I just want that. I don't want the second. I want the unit prefix, right? We've got all of our stuff here. We found our node with the number 5. Then find the substring of the units, right? So this is the attribute units. We're now looking at it like it's a string. Find the substring, get the first digit, count to the one thing, right? So 1 digit. And in this case, it would be the letter U. Okay, enough XPath. Let's talk about XSLT, the reason that we're really here for. Remember, XPath is the tool. We can't live without it. We have to learn it just like regular expressions or other things like that. But now let's get on to the meat of the problem. The purpose of XSLT is to do the manipulation, to parse, search, and manipulate the XML that you get, or really any tagged language, but particular XML. You can do it with HTML too. It can use to transform XML to other XML. We can use it to you can imagine a real common example that's done is to take an XML source file and format it into some cool looking web page. This is sort of a dynamic HTML, right? It updates based off of a file. So you have these processors out there, and the processors are the programs that take in an XSLT file as well as some data and then give you some result, right? XSLTproc is the one that we'll use in our examples here, which is a GNOME implementation. It has very basic features, and it has only the first version of XPath, so there's a few keywords that are missing. Sometimes I find myself fighting this, but that's all I get from XSLT. And it's a bash scriptable guy. 2 other ones that are real popular are Saxon, which is a Java implementation of this. This is a very sophisticated one, and Microsoft's MS XML package. These are both libraries rather than standalone programs, but they have very, very advanced features. They always keep up with the latest stuff. So if you need a library for processing, these are a potential way to do it. So let's talk about some fundamentals of XSLT. There are two conceptual files that are important when you're talking about XML processing. The XSL file defines the rules, and that's what we're going to kind of focus on, is generating that. And then you always have a source file. So you don't generally write standalone programs in XSLT. You write ones that will take in a file and then dump it out. And then what it does with that depends on what you do. If it's XSLTproc, you can pipe it through bash scripts and do all sorts of other neat stuff. If it's a library, you could move it on to some other processing portion of a bigger program, like a web server. XSLT has a concept called templates, and you're going to see this used all the time. Think subroutines. They provide all of your basic action. This is how you slice up your program. But they're a little bit more than just subroutines, and so that's why we're calling them templates. We'll see when we start getting into that, but templates are where it's at. XPath is going to be used to know when to apply. It's sort of like your search routine. Remember, we said we wanted to separate out querying of data. That's what XPath gives us from the formatting of the output. That's what XSLT gives us. Okay, so we're going to use XPath to search around the XML and then apply templates based off certain criteria. Okay. One interesting note is you can interleave XSLT programs with other tagged languages like HTML and SVG and other things like that, and even other XML. So the way that they do this is everything that does not come into the XSLT namespace, right? So it has XSL : in front of it, is just simply copied from input to output. There's a slight exception that we'll see at the very end of this, but for the most part, if you want to add your own stuff or if you have other stuff, you can have XSLT living within an HTML file, and it'll still process as long as you've got the namespace in there. And lastly, this concept of whitespace we're going to revisit in detail, but all the text between XSL tags that isn't pure whitespace is copied. That's another way of saying the same thing, that we can interleave these other tags. But if it's not pure whitespace, if it is pure whitespace, then it will be copied. We'll see that later. Okay, let's jump into a specific example, and we've got this motivating example that I love using all the time, which is the same basic thing. We have a XML file, and we want to create a CSV out of it. We want to create a CSV that shows the status of a laser turning on and off and the time it occurs. So here's what that XML source file might look like, right? We saw it a couple of times before. We have programs. Programs have events. Events have times. Events also have actions like laser on, laser off, and those lasers have some sort of identifier, which we call channel. And we have a combination of content, that's space in between the tags, like the number 5, 15, 55, and so on. And then we have attributes as well. So cool, right? Take this, turn it into a CSV because someone wants to use Excel. This is what the result should look like. We should have some sort of header up at the top, and then rows of a time column, and then the status on and off and on and off, okay? And we want the words on and off. We don't want a different version. We can also have nothing in there as well. Okay, so let's start taking a look at what that might look like. Here is the source code for shock value. That's our source file, and this is what the XSLT program would look like. We'll go into detail in each section here in just a second, but what you always have is you have some sort of header up at the top with some output definitions, and then a series of these templates that run through. And you have this XSL namespace running around with little gizmos. They do things. That's our little macro language that we talked about, how we might use the data. Templates search for the data. XSL tagged elements recall that data, And then everything else is however you want to decorate the outside. So there's the data glob, and then what you put outside, like commas in our CSV example. Okay. Let's talk about those important XSLT tags for the moment. The most important one you're going to use a lot of is called XSL value-of. It has an attribute called select, and think select, when you think select, think XPath. When you think XPath, think databases. That's why they use the word select. It's like a select query in SQL or something like that. All value-of does is takes whatever the result of that XPath is. So you've compiled it, you've calculated, you found that end node set, and put it out to the output. That's it. So you can see why this is such a basic thing, and it's the number one thing. Templates, as I mentioned, are subroutines or functions. They're not quite exactly a subroutine, though. So let's talk about what's inside of it and why. The first thing that it has is it has a match inside. A match, just like a select, is some XPath. But what's going to happen is you're going to calculate this XPath, and then you're going to apply this thing like it's a for loop on every node in that resulting XPath. So remember when we had our two different start times from our example query. It would be applied to both of them if we stopped there, if we didn't refine it with a predicate or something. Okay. And lastly, we have, so this is required. Lastly, we have a thing called a mode string. And a mode string is kind of like a name for the template. And you can selectively call these templates by giving them different names and then pushing them around. Okay. Because remember, the template will follow everybody who matches this XPath. It's a for loop, so you're going to go through the entire node set. So you might need a name to differentiate one from the other, because you can imagine having different templates for different tools that all have the same basic XPath. Right? Sometimes I want to use start time to calculate a number. Sometimes I want to use start time to output the result. I don't know, whatever. Okay? Mode is optional, though. And we'll see later what some of the side effects of not having a name is. So template defined this kind of subroutine type of thing. To use it, we use a tag called apply templates. It has a select query. This has a match, which means I will allow anybody who meets this pattern into the guts of this template. Here, this is the outside. This is sort of like calling the function. And so we're going to give it some input data. Now, usually you'll see that this is more constrained than this. So for example, this might be some long XPath expression from the root node all the way down, whereas this guy is kind of as short as possible. This will process all elements. This one will select specific ones, right? Remember, node sets can be refined over time, and we got smaller. And then if you want to use the mode name, you can, and that would match up a specific one. So again, this runs a template on some particular one. The select feeds it's not the input data as much as the types of nodes it's going to operate on. We'll have something else for input data. But always think of this thing like it's a for loop. Second set of important XSLT tags. The for loop itself is called for each. And what you're doing here is you're quite literally explicitly creating a for loop. This is not a template. It's not a subroutine. This guy is done inline. Remember, templates had that implied for loop. This guy here is explicitly saying do this each and every one of them with some XPath. And between the opening and closing tags of this for loop is whatever's going on inside there, right? So you could have a bunch of value ofs inside there or something like that. So this is making a loop. Now we want to be careful. The XPath that you define in here creates a new cursor. So the period operator in our XPath that said the current node is different inside here than it might be from the outside. We'll see an example of when that comes into play. I said before we can feed data into a template. And we do that with this thing called parameters. Right, so the parameters tag, the param tag, names something, and it lives inside the template definition. The with param is the converse of that. That's saying use this specific data from this XPath and call it that parameter name. So this is a little closer to like feeding something data. Parameters are decoupled from the matching function of templates. Remember, templates had their little built-in for loops, so they're given some data. If you give something a parameter, it does not change. So it's a way of feeding in kind of constant data. It's not truly constant. You can change it as much as you want. Stuff. Okay? But with param is used in the apply templates tag to pass stuff. So with param goes inside of apply, param goes inside of template. You can create variables. You can create collections of variables. Obviously, they have a name. And there are two formats for giving the data in. You can use a select query, which will grab you a node set inside of XPath. Or if you want to assign that thing like some raw string or some calculated value or something that doesn't fit well into XPath, you just simply have an opening and closing variable element, and then you put whatever inside there. And this will be generally interpreted as a string. So it defines a variable for later use. You access this inside of XPath expressions just by putting a $sign in front of it. So it's another way of, we talked about labels, the add operator, and then there's no, for elements and stuff. This is a third way, the $sign. And now this is a key thing. You're going to get caught by this the first time you do it. Variables cannot be changed. You define them once, they have the same value, they never change. So think of a for loop for n equals 1 to 100. You should be able to look at the value of n every single time. That's normal in a Python or a C++ or Java or something like that. Not so in XSLT. You want to think of these variables like they had the word constant in front of them. You define them once and go over again. This really tricks people up. And Stack Exchange is your friend for this. For example, counting loops. Just go to Stack Exchange, use the XSLT cookbook. That's a great one, or the XPath cookbook. Great resource. But you have to work around this problem because it was there as a security feature of a language. These run on web servers, and you don't want malicious code running around in JavaScripts and stuff like that that might use XSLT transformations. So they decide to make variables non-changeable. Here's some less important XSLT tags, right? These are a little less commonly used, but certainly very much worth knowing about. The choose operator. I didn't put the closing tag on here and stuff, but you can see a choose is like a switch case statement, and it's based off the binary value of some XPath. So it will evaluate an XPath and say, is it binary true or false? So if it's a node set, the binary value of a node set will simply be, is it empty or not? If it's text, it will say whether or not the text is empty text or if it has any content in it, like we did when we searched for the number 15 and stuff like that. And then there's this otherwise. So you can stack a bunch of whens, and between the opening when and the closing when is whatever will happen when that condition is true. It's bad practice to have multiple overlapping select statements. So Stack Exchange will help you with that particular thing. And then there's the catch-all of the otherwise. Cool. We also have an if statement. Okay, if is a shorter version like choose with some limitations. It creates a single if statement. Whatever's in the ellipsis here between the opening and closing tag, that's what happens. It only runs that code, doesn't run anything else, and there is no else keyword. If you need an else, use choose. Okay, this is for short stuff. A very underrated tag that you will find yourself using more often, it's surprising how often you use this one, is called text. And text just simply says, it outputs the content verbatim. That's it. There's no processing inside here, no nothing. If there's white space, it is always kept. if there is dollar sign values or something like that, they're done as dollar signs literally and stuff like that. And this is very useful for fixing white space problems, as we'll see in a little bit. There's a derivative of the template idea called a call template. This is similar to an apply template, but it does not iterate. It's useful, so you notice there's no XPath in this. There's a name, but there's no XPath. This is useful when you want to just kind of call something that does a short thing. It's not data dependent, or the data is already inside a parameter. So there's no need for XPath, and we will actually see that here in just a second too. I use this and apply kind of for different reasons and stuff, but it's not nearly used as often. It's still very useful. Okay, now that we've seen some of these XML tags, let's see what it looks like in our problem. To begin with, we're going to break down our problem again in pseudocode. That's the key to understanding this XSLT. We're planning ahead what we're going to do. So here's our input XML. This is what we want. And the first thing we're going to do is we need that header. We need the header for a couple of reasons, but one is to actually draw the line that is the header. So we're going to find all the unique occurrences of the channel attribute. That's our first task. Okay. You notice that the word channel shows up in a lot of places and there's a lot of duplicates. So I want only the unique ones. Then we're going to write that header out. We're going to write a header by putting the word time, then a comma, then each unique channel that we found above with a comma, and then a new line. That concludes the header line, the header row of our CSV file. Then we're going to start working on the content rows. What we're going to do is loop over each event, because each event will be a row. From that event's start time, we're going to write out the content of the start time, the units attribute, that and then a comma. That corresponds to the first column of that, right? The time column. A number, which is the content, the space in between the opening and closing tags of start time. So we call that the content, sometimes called the text. And then the units attribute, which is this US, MS. I noticed that I have a microseconds and milliseconds sort of interleave, so whoops. And that concludes the first comma, the first column. Then we get into the data columns. For each, now we're still in the event, but now for each child that has a channel, because remember we have laser on, laser off, so we can't exactly say whether or not it's the name of a specific element or tag. We can't use laser on or laser off because it might be something different. Maybe there's other operations going on besides lasers that start with on and off, or end with on and off. Then we're going to take each one of those channels inside that, and in the order of the header. This is important for CSV. Once I define a header column, I have to do everything in the same order. And you notice a couple of cases in here where TISAF is the first in the XML, but it's actually the second, the second data column, the third actual column. So we can't trust the order. That means we have to go back through that order in the way that we define the header. So in that header, write out the child tag's name. This is not content like we did with the number 5 and 15 and everything like that. It's the name of the tag with the prefix laser removed. So we're going to do some string processing. End it with, or separate it with a comma, and that concludes that second for loop, which we then terminate with a new line. And that's the end of it. So mapping the pseudocode to the XSLT is fairly straightforward. We're going to break up each one of those pseudocodes and see what the code in XSLT looks like. Here's our source program. And the first rule of our pseudocode was find all unique occurrences of the channel attribute. That is an XPath expression. right? We want a node set that has just two, in this case, two channel attributes. The nodes, remember, can be attributes or elements or content or whatever. So we want a set of attributes, and the values of them should be unique. That's what the XPath looks like. Now, it's dangerous looking. It's very ugly. Finding uniqueness is something that you should just go for Stack Exchange for, but just the glom the details off and get to the important stuff. We want to create a variable, and we're just going to call it headers. And here's the XPath. We're going to say look for all events, look inside that event's channel attribute, and find any one that hasn't been seen before. That's all this thing is doing, is saying, I want to make sure that the channel's name is not a name I've seen before. Again, let's go into Stack Exchange to decode this and stuff like that. But that's what we've done. We've found a unique set of all the channels. Good. Now the second thing we had to do in pseudocode is write the header. This sounds like a job for value of, and it is. We're going to create a call template called doHeader. Remember, a template was just like a subroutine. We're going to give it the parameter of headers, right? The thing that we calculated in this variable. And we're going to, in doHeader, we've got a parameter named headers. So that means that we're going to pass our variable headers into that headers. That way it's always just called headers, right? So we're just saying the XPath is the variable that we're passing to this headers name. And we're going to use a call template. Why? Because headers, the variable, has all the information. We don't need XPath anymore. We used XPath up at the top. And the programming of this is not necessarily the most efficient and stuff, but it is illustrating the point, okay? So we're going to call this doHeader, and then we're going to end it with the new line. So what was doHeader? doHeader, remember, was put the word time in. So we're going to wrap that in the text keyword. Time with a comma. Then we're going to do a for loop for each of the things in the headers. Find the value of, and I've got the cursor here, right? The period in there is being written back out. Why? Because this headers variable was defined to give me channels, channel attributes. So if I already have channel attributes, I'm just saying, give me the text inside there. When you can think of this in an object-oriented language like casting. The node is a attribute node, but when I cast an attribute node as text, like I would do in a value of, we just simply get what's in the quotation marks, right? We get the microseconds in the, or sorry, we're talking channels. We get the channel text string. That's what happens when I casted the entire thing in there. It'll just do it. I could have also said it as slash dot slash text, you know, which would get the actual, or dot slash value, which would get the actual content in there. And then of course we've got to add our separator, comma, which I've wrapped in text guys, and that ends the for loop. That's the header. Remember, the terminating new line was done outside the template here. So that's it. Time, each of the headers, comma, new line. Cool. Half the problem is done. Second half is a little more complicated, but not too bad. Remember, we want to say loop over each event. These are the data rows. Loop over each event. So let's create a loop. And we're going to do an apply templates. We do want XPath in this case because we're just simply going to say, give me all the events. I could have done double slash events. I decided to say, find all the events below the word program. In this case, it's the same. And we're going to apply the template. We're going to have this template with a mode called doEvent, right? That was just the name we gave it. We're going to give it that header parameter again, and we're going to see why here next. From the start time tag, we're going to extract the content and the units, right? So that was our first column of the data row. So I've got a template, doEvents, that works on events. Remember our idea that the template was more generic, and the apply templates, the calling function, is the specific set that we want to use. So this guy will accept any event. Events have all the data that it needs, so you give me a list of events and I will do it. And this will generate that list. It needs a param called headers. Cool, no problem. I'm going to create a variable for later storage called this event, and it's the current event. And you'll see that one in a second, but we'll skip that for a moment. We were talking about the first column. So I need the text of the start time, the thing in between the starting and closing tags, the content. So there it is in a value of, in a slightly little XPath. Remember, this start time is relative to, it doesn't have any slashes, so it's relative to the current event. No problem. And then we're going to append right after that the value of the units on that same start time, right? So start time is a unit of microseconds or milliseconds, whatever it is. So it's going to give me the number, then it's going to give me the units. It doesn't matter that I wrote them down in the tag that the units were before the content. No problem here. And last but not least, our trusty comma. Now comes the fun stuff. The rule was for in the order of the header channels, extract the trimmed name of the tag. So we're still inside of our event. And we have now a for loop. There's actually two of them. For each of the headers, that's the first part, extract the name of the tag. We're going to skip that trimmed for a second. Extract the name. So for each of the headers, I'm going to save the current header. Notice my cursor is about the for loop, not about the event one like it was earlier, right? We're inside of a for loop. And so the cursor is about what the for loop is doing, which might be completely different. And sure enough, it is because its source data was given as a parameter. So for each of the headers, save a variable called this channel. I didn't have to do this, but it really makes the XPath a little easier to read. So this channel is now saved. Then for each of the events, remember how I saved the event up top because the cursor would move around when I did a for loop? So I saved it. I can save a variable that's an entire set of nodes. So this event, this current event, the current event, find anybody who has a channel that matches this channel, right? This outer loop is enforcing the order of the headers. This inner loop is selecting a specific one. Now, this is probably not efficient code because I have a loop within a loop. I can refactor this, but you know, it's kind of easy to explain. Now, the star was important because remember, an event might have a laser off and a laser on. It might even have a lot of stuff that has a channel in there. Maybe I've got a water pump on, or a camera on, or a camera off, or whatever. You know, anything I want. For lasers, though, are two that we're looking at here. So either one of them, the star means a wildcard. Anybody who has a channel that matches that, we're going to keep it. Then our trusty value of, which outputs the result. This is where we do the trimming. Notice the name, which is the name of the tag, different from text that we used before to get the stuff in between tags. This is the name of the tag, of the element. So you also see this sometimes as local name, depending on which version of XSLT and XPath you're using. We're going to skip the first 5 bytes. So start at the 6th one. And if you count LASER, cool, that's number 6. So we're starting at this one. You can also do negative numbers. It's a different thing. It's not substring, but it's a different function. So we could have done it from the back, and I could have possibly done it that way too. But this one was easy enough with lasers. So we're doing string manipulation. And the for loop, which has the wrong indent for some reason, and the for loop, and then top it all off with our always necessary comma. So the headers define the order. This defines a search for that within there, and then our comma. In the order of the channels, extract the trim name of the tag. Cool, almost done. What else is left? Oh yeah, the new line. So that's just static text. Just like before, we have a text variable. And you may have noticed before that I have this weird looking ampersand # thing. This is the standard W3C SVG version for a new line. There's a couple of other ways that you can do enforce a line break in there, but this one was actually the cleanest way of doing it. So this is an XML understandable code to say this binary value, which is hex 0A, which for anybody who knows, their ASCII table is the new line character. So that's a standard way of forcing a new line in there. We wrapped it in text, so it's not confused with any of the XSL stuff. Well, that was it. That's the whole program. Is there anything more interesting to look at? Let's talk just briefly about running those programs, right? We talked about the major players in there, Saxon and MSXML and XSLTproc. Remember, XSLTproc supports XSLT 1.0 and XPath 1.0, and there's a couple of keywords that are missing in different versions of it. So I don't know why no one's ever updated XSLTproc, but whatever. Let's just look at what it looks like on a bash prompt, right? This is me running in Cygwin and stuff. So to run it, it's a command line tool. The other two are libraries, so you have to build some software around it. We just give it the XSL file. So this was called XML2 CSV, and then here's my YouTube example. And it just outputs straight to the standard output. Time, a channel, a channel. Time column, on, off, on, off. You notice, if you remember, that there were a couple of ones where I didn't change, like I think the first column is a Heaney, second one's TISAF. So at 15 microseconds, we never did anything to the TISAF, and that's why it's blank. That's good, that's what we want. I also at 125 didn't do anything to the Heaney and change the TISAF. That's good, that's what we want. Notice the blank commas in there. Everything did what it was supposed to do. So this is a good running program. Okay. It looked too easy, right? Because it was. There's some gotchas in XSLT, and once you know them up front, your life gets a lot easier. Stack Exchange is full of questions with these same questions asked over and over again. Two areas that will focus you. One is Whitespace, and the other is built-in functions. Whitespace. Tagged languages like XML do not care about whitespace because the control is done in the tags. The content is the only thing that matters about whitespace, and generally that's not the interesting stuff. Okay, and things like HTML, actually their paragraph thing strips off whitespace because you're not supposed to be putting in whitespace in the standard HTML 1.0 type of style of doing things. So they are purposely saying stop screwing around with whitespace, except we lived in a non-tagged language world. XSLT can cause problems when it starts inserting whitespace, and this is a problem when you're trying to generate code like a CSV or Python code, where whitespace, which includes new lines, can change the data. So be aware of this. The rules for XSLT, I said it at the beginning, but let's just say them again. This will not output the whitespace when only whitespace is in between XSL tags. It will not do that. And this is what throws you off because it looks inconsistent, but it actually makes sense. If it's XSL mashed with another XSL and it's just whitespace, new lines, spaces, tabs, whatever, it will not put that in there. Otherwise, it will put all the white space, everything, every little thing, and this is what gets you. Okay. Let's look at some examples. Here is a very simple thing of two value ofs. The first one, the number 1 and the number 2, butted right to get together with each other. You can imagine this being in the middle of anything. Remember, value of dumps it right to the output. The result looks like this, a 1 followed by a 2. The number 12, if you want to view it that way. We can mash that up a little bit and say, what happens if I put them on 2 different lines? And the result when you compile this is the same. Why? Because XSL followed by XSL with this new line in between, the new line gets stripped away. What happens if I put a comma on the end of just one of them? Just one small change. Do I get a 1, 2? Absolutely not. I get that new line back again that I was not getting before. So anything that's printable gives you all of the white space back again. How do I fix that? Well, like this. This guy here is the same thing, except I've inserted my comma inside of text. Now this looks clean again because they're on different lines. It's not one long line. We're trying to avoid that. And I put the comma inside of XSL text. So the result of this is 1, 2. Why this white space is now removed again? Because XSL to XSL. It doesn't matter what's going on here. It matters that this tag to this tag, that's white space, it's removed. So we will use XSL texts a lot. It's very easy to not do that. You notice that it copied the comma. I just did it with screwing up my white space. Okay, so there you go. Built-in rules are another gotcha. And this is probably the most frustrating ones because people don't even know what to search for when they see this problem. It's so bizarre. White space, okay, you can at least know that the word white space in XSLT is going to be somehow in your Stack Exchange question. But built-in rules, you don't even know what the word for this problem is. Remember that templates act like a match attribute. They act on a match attribute, which is an XPath pattern, right? That's how we did them. And they had this built-in kind of for loopy type of thing. The built-in rules are a set of things that all XSLT processors will do. It's not a bug. It's in the documentation. They wanted this for some reason. Every time you create a template that has a mode, every mode automatically gets, even though you didn't type it down, a free rule for the XPath of text and @*. Remember, @* would be any attribute. There's a couple of other ones too about comments, but these are the two that really trip me up. Okay. Now notice there's nothing before and after the text. Okay. And remember, text was the content, the stuff in between tags, and sometimes white space if you're not careful, right? So you got one of these every time you make one, and they will pop up in the weirdest damn places. Let's look at an example. Here is a fairly small little thing, okay? And it just says, here's a top level template that matches anything. And we're gonna apply a template on any of its children called my template. Right? Now, I put in a match condition that says we're only going to do with a program. And if you remember, I think, there we go. If you remember our XML source program, right, we only have one program tag. Okay? And all this should do is say the text, this should not occur. All right? And I sort of spoiled it by saying what happens when we run this program with that input. Well, we get our line should not occur. That's cool. We got that. But then we get all this other crud. What the heck are these numbers coming from? And what's with all the weird random indentations and the fact that they're duplicates and also that they're empty spaces? What the heck is going on with all this? Well, if we look at this thing again, we see that the numbers we're getting are actually content. 55, 5, 15, they're happening. And they're all happening twice with different amounts of dead space, we'll call it, right? A spare line. And they're doing it with different indents. Remember, these built-in rules are applying to all text. So it's like someone also wrote down a template match text mode my template. What did they put inside there? They said just copy the text again. So these default rules are copying back out. Anytime it sees content, it's going to copy it back out. That wasn't what we wanted. We were doing selective stuff on this. We didn't want anything just because it was there. So the indentation is about how these two interact. You know, anybody with anybody. It's going to actually start implementing this white space, then this one, then this one. If you were to look at the white space in here, you would see multiple versions as it goes through the indentation and eventually gets to 5. Then it gets back down again and says, well, there's event, program event start time, but there's also just start time by itself, and there's event by itself, and all these. So there's these different permutations of it. Okay. How do we fix this? The answer is, now that you know that these rules were done without your permission, you can override them. And override is very simple. Here's the same program again with a slight tweak, new text, but we added a new line, a new template called myTemplate with a new match of text and any attribute, the 2 default rules that were screwing us up. We gave it the same mode, so anytime we called this template up here, myTemplate, it was gonna run one of these anyway. We just simply turned it off. Basically, we made it an empty rule by having a template with no content inside. There's nothing inside that template, so it's an open, a self-closing tag, and that's how you override this. Books and Stack Exchange and lots of places talk in much more detail about this, but this guy will do it. The point is, anytime you create a custom template, make an override right there next to it. So you will always have 2 templates with the same mode name, one with whatever your filter is and one with this default. If you have 3 or 4 for different permutations of myTemplate, one with program, one with event, one with whatever, then you can still reuse this. It's only when you create a new mode. And the default is one. The no mode is also one of them too, so watch out. When we do that and we run our program again, this should be right. And sure enough, when we run this bottom program, same source data, oh, thank goodness, it took off all the guts. So all that crud is gone. So it does work. One last topic, because this thing is running a little long, which is the idea of an in situ or inline value of, right? So remember, value of was our main sort of workhorse for copying data from the XML into whatever our output format was. But a lot of XML is about one particular pattern, which is one tagged language to another, or particularly XML to XML. If you think of HTML and SVG as just simply XML without specific namespaces, then that's cool. So let's look at a better way of this thing, and it's best done with an example. We're going to take our same example again. In this case, we're going to make our CSV into an XML file, a CSV-like XML. So we've got this. We already have code that does this successfully. We want something that looks a little bit more like this. And this is not the same source thing. There's no program or whatever. This is just simply CSV, like it's row and column. Rather than event-based, it's row and column, and I've changed the tags around a little bit. Okay, start time is still called start time, but it no longer has content. It only has an attribute. And the attribute value is the whole thing. So there's no units and then a number. We're not doing that anymore. Okay, so I want to make this out of our source file. And we got rows and stuff. We also always have both of our lasers. They're called actions now. They're no longer their own tags. All actions are the same, and they all have the channel, and it's in the same order every time. Even when, like this one here, this TISAF does nothing, so it just has a blank value, but it still has an action associated with it, just like we needed with the CSV. Order is always the same. Both of them are always there. Start times are the same. Okay. So what does that look like? I'm not going to go detailed through this because we're running long. But it's a shorter program. This is the whole thing, except for the decorators at the top and the bottom that XSLT needs. But this is the program core. And you can see we've got one template at the top that's applying some template. A lot of this is the same. And then one template at the bottom for do event. There's no longer a do headers because we don't need a header anymore. That wasn't part of our specification anymore. Okay, so what's new about this? 2 things. Number 1, custom tags. there's some tags in there that are not XSLT ones. When we run into those, we will get all of our whitespace problems like we had before, but now we're in a tagged language that doesn't care about whitespace. And it will just simply copy those things the way that they are. It just moves forward through them. Straight copy, doesn't understand them, doesn't care about them. And then, so anytime you see that, we have CSV-like, that was our top level one. Here's our rows. We had our start tags and everything like that, right? So we created these things inside. And we also have inline XPath expressions. This is how we're actually generating the content. This is why you don't see any XSL value ofs in this guy, or it shouldn't be. And the reason is because we're using inline XPath expressions. Remember, value of just simply solved an XPath. So what the format is curly brace inside of an attribute. Once you've got the curly brace with the quotes and everything like that, any XPath inside here is fine. And in this case, for action channel, it was the this channel. Remember that variable we made, right? So it's got a $sign because it's a variable, and we defined it above just like we did before and everything like that. Everything looks pretty good. I clean this up. There's no longer for loop within for loop and everything like that. You also notice that I can have not just variables, but whole XPaths in here. When I did the action, channel was just the variable, but the value was that whole substring, name, trim off the word laser, and so on like that, right? So all of that is, we even do a concatenation over here, right? That's how I built the start time thing. We concatenated start time, that's one XPath, and start time / at units, so the units. So I take the value or the content of start time, append it to the units, the content of the units attribute, right? And I end up with things like 15 microseconds and 15 milliseconds and so on. Okay, a very short, simple program that transposed it. The real piece of work on this thing is building up that headers with the non-repeatable unique values. The rest is really easy. So I hope you like this video, this XML video about XSLT and XPath. Like I say, this is a really neat tool if you're doing a lot of heavy work with XML for data processing like I am, and it really works quite well once you get the esoteric language things out there. Keys are know your XPath, know the weirdnesses, and get around this idea of how variables can't change. The rest of it is actually fairly simple markup type language or macro expansion language and stuff. So hopefully you had fun in the last hour learning a new skill. Another video we're going to do is we're going to take this XSLT and the schema stuff, the two previous videos that we did, and turn them into an automatic code generator for a language, like in this case C++, but you could do it in Python or anything else, by taking the tool of the schema definition and the XSLT and XPath processing and turning that into a fully working code generator that builds empty classes, builds template classes for everything that we're going to do. So thanks a lot. I will see you later.